Hello class, this is PBasic commands number 6, and in this video I plan to talk about this output command, this input command, and these two control commands. Let us begin. First, let's go back to the microcontroller block diagram, and we indicated that you can read information uh, line by line or in parallel, or you can read it in serially. And likewise, you can also write to several pins at once as a code, or you can output it as a serial bit pattern. I'm going to be using the analog to digital converter. And the analog digital converter that you're using in your project takes a voltage and it converts it into a binary code or binary number. And the size of that binary number is 8 bits or 1 byte. Now the command that's used to read the value from the analog digital converter is called shift in. Basically, it shifts in the bits one by one. So after the first clock, the first bit comes in, the second clock, the third, the fourth, fifth, sixth, seventh, eighth. So after 8 clocks, all the bits will have been received by the basic stamp. And this is useful because you can get your information using only one pin as opposed to having 1, 2, 3, 4, 5, 6, 7, 8 pins to read the value. So it's very beneficial. And to initialize the analog to digital converter, you need to output a single pulse. This sort of like tell the analog digital converter to get ready. I'm going to ask for information. So the pulse out command allows you to output a single pulse, and you can decide how wide this pulse will be. And then you follow it with the shift command to shift in your information. All this is taken care of by the command. So it's going to read that value into the CPU as an 8-bit or a byte. So now we have the value that's being read. And what are we going to do with that value? Well, we're going to test it because we are checking to see if it's above or below a value that we choose. And then we're going to use that value to either turn an LED on or off. Let's begin analyzing the program quickly. Once again, I've defined the directions of my pins, and I've defined one variable that I'm going to use to save the value coming from the analog to digital converter. These are constants that I have defined for the pins that I'm using to control the analog to digital converter. I initialized the number to 0, and now I'm going to go through the steps for getting the information that I want. First, I turn on the chip and then turn it off. I initialize my clock to 0, and then I output a 210 microsecond pulse. Actually, it's 420 microseconds because whatever this is multiplied by 2. And then I will shift in the information and store it as an 8-bit value. And just so that I know what I'm receiving, I'm going to display that value on the debug screen. Here is where I will process what I've received. I will check to see if it's less than 100. If I am less than 100, then I'll go to the first process and I'll turn off the LED. If it is greater than 100, Then I'll go to the second process, which turns on the LED. So once again, this process here, all of this is reading the inputs. Now this is just an extra command that I've added into the program for debugging, or troubleshooting. So it really doesn't belong anywhere in the actual process. If I go to my microcontroller, there is no debug screen connected to my system. It's something that I use when I am developing my final program. In the end, when my project works, the debug command will have no value other than to just display interesting information while my program is running. And most of the time, my process will not be connected to the computer, so this command will not show. But when you are doing the development work, you really do need this to help display information that's going in your process. So summarize once again, these 4 steps is the read, and this time I'm not reading a single bit, I'm reading 8 bits at a time, and 8 bits can be any number between 0 and 255. Then I go to my process. I'm checking to see if that value is less than 100 or if it's greater than 100. It's either going to go A or B, which means over here it's either going to go this way, it's either going to go this way, and if it's not less than or not greater than, then it will just carry on and just repeat and do nothing. Of course, this is happening at lightning speed, so it happens instantly. Now the final part, which I like the most, is the demonstration. First, I download the program into the BASIC stamp. You can see here that it is reading 0 from the analog to digital converter, and I can show you quickly that the LED is off. Now I'm going to make the number larger than 100. So I'll go back to my BASIC stamp, show you on the debug screen that the number is increasing to a number larger than 100. I will return back to the video and you can see now that the LED is on. Why? Because the program says it will be on. The program did say that if X is greater than 100, then go to the second process, which turns on the LED. Again, if I reduce that number, decrease that number to under 100, you can see once again that the LED has went back off. So my program is actually working as I planned. This is the process control loop. This gives you a chance to use the other commands, pulse out, shift, and the if statement. Thank you.